Our first tissue that we arrive at is called areolar tissue. Sometimes it's called loose areolar as well. And this is a very, very cool tissue. And the reason why is this. This is the only tissue that has both a large amount of elastic fibers and a large amount of collagen fibers. Now, you're going to see a lot of connective tissues that have one or the other. You're going to see a lot of the cartilage has collagen fibers. You're going to see that the other dense tissues, dense regular, dense irregular, has collagen. You're going to find elastic has elastic. This is the only one that you're going to see that has large numbers of both proteins, collagen and elastic. So, check it out. The purpose of a collagen fiber, once again, is strength. The purpose of an elastic fiber, once again, is stretchiness or flexibility. So we have the best of both worlds here. We have strong stuff that can also stretch and not get torn. So just an awesome, very versatile tissue. Now, where is this found in the body? Kind of everywhere. It surrounds a lot of your organs. The outside part of your organs has this connective tissue called fascia. Some people pronounce it fascia. That's fine too. You'll hear me say fascia. It's not incorrect or correct either way. Fascia. And what fascia is just this thin film of this type of tissue that is both stretchy and very, very strong. And a lot of times, unfortunately, this fascia can kind of get bundled up on top of our muscles, and that's what causes a lot of our trigger points and muscle soreness, where you got to go get a massage or stick an elbow in it to loosen it up. Sometimes this stuff can get bunched. So if you look at this picture to the right, you'll see a couple things. Let's look at the top right first to show you the diagram. So what I see is a whole bunch of crazy string-looking things. And then you see a few purple dots interspersed throughout it, right? All right, so let's talk about each one. Can you appreciate the fact that there are both thick, kind of purple-looking strings, and then there's skinnier purple, like smaller-looking strings? So we have a thick one and a tinier, or not so thick one. The thick one is called the collagen fibers, and that kind of makes sense, right? The purpose of collagen is strength, so it would make sense that these are a lot bigger than the tiny little hair-like proteins. Those are the elastic fibers, or the elastin proteins. So those are going to be a little bit more stretchy. So once again, best of both worlds, strength and stretchiness. Now, the cells that you see interspersed throughout the matrix are called fibroblasts. Now, this is the first time we're introducing this suffix blast, but we'll see a lot of this down the road. What a blast cell is a stem cell. So here you see I'm circling it right here, fibroblast, and blast refers to a stem cell. Now, what is the job of a stem cell? A stem cell specializes in mitosis. I'm going to write it over here on the left because I'm out of room. A stem cell is a cell that makes new cells. So they're very, very good at that cellular reproduction, that interphase and mitosis, and also meiosis. Okay, so G1S, G2, and then the PMAT cytokinesis. That's what these cells do for a living. So the prefix to this word, fibroblast, fibro is referring to fibers. So what does this cell make? It makes, well, what it's describing. It makes fibers. So as we age, as our life goes on, some of these elastic fibers get too stretchy, and they can get torn and damaged. Some of these collagen fibers will weaken over time, and they will get damaged and fall apart. So we do need to make more of these. How do we make more of them? These cells right here, the fibroblast cells. So they are stem cells that actually they spit out this matrix, all this space that you see in the picture, and they also make both the collagen and elastic fibers. So if you look at the picture on the bottom right, you can see that we have a bunch of darker pink lines. I'll try to highlight them the best I can, but you just kind of see this big glob of pink. Here's a really good one. Big pink rectangle. Pink rectangle. And then you can see the elastic proteins are really easy to see. They're the kind of, once again, skinny hair-looking structures. And then you have a lot of fibroblasts in the picture. So these fibroblasts, once again, their job is to make these proteins. And then one extra note with the areolar tissue is you can have some immune function. You do have some cells around the organ that help with just protecting that organ, making sure that it's safe from infection and other disease processes. Our next connective tissue is called adipose tissue, and generally we're going to interchange this with fatty tissue. Adipose tissue is made up of a bunch of fat cells. Those fat cells are called adipocytes. So anytime you see the suffix "cyte," that means mature cell. So this is a fatty cell or an adipocyte. The function of fat is several things. Number one, it supports you, it protects you, right? We do want a little bit of fat around our body. We also definitely need it around some organs, such as the kidneys and the heart. Those are probably the two most important. We need a certain temperature around the kidneys and heart for them to work properly. Also, you have a lot of fat inside of your brain, believe it or not, in your spinal cord. And without it, you get some serious disease processes and really bad symptoms. So fat is a good thing. Just like anything though, you don't want too much of it, right? You don't want too much water, you don't want too much calcium, you don't want too much fat either. So, but you don't not want any. You need some fat. Reason why, not only does it support and protect us, it's also an emergency backup plan in case we get stranded on a desert island or deserted island, excuse me. A desert would work too. If you get stranded in a desert, that would be a problem. And if you don't have access to food for a long time, you will need some calories to keep you going. And the reason why it's possible to live 1 month, 2 months, 3, even 4 months without food is because your body can break down your own fat tissue. You can even break down some of your own bone marrow and muscle tissue in order to survive. So it's a survival mechanism. And then last but not least, another thing that fat does is it gives you insulation. It keeps you warm, right? Think about a bear hibernating during the winter. They eat a lot of food in the fall, so they get nice and big and fat. So then as they sleep for 3 months and they don't eat that whole time, they don't die. They have enough energy to keep their brain and their heart pumping and everything moving while they're sleeping for that entire time during the cold months. So same thing in our body. The more fat you have, the warmer generally you will be. So you take a look at what adipose tissue appears like under the microscope, and really it's just a bunch of fat bubbles. It's just a bunch of marshmallow-looking circle structures. I've had a few students describe it as chicken wire. If anybody knows what chicken wire looks like, if you can make the connection between this picture and that, more power to you. Otherwise, to me, it just looks like a big bunch of white bubbles. And those white bubbles aren't empty space. They're actually filled with fat, with adipose tissue, lipids, if you will. And another cool thing about adipose tissue, if you notice down here, that because the adipocyte, the cell, gets filled up with fat so much, the nuclei actually get pushed to the side and sometimes get crushed. So this cell in the cytoplasm is mainly 99% lipids, 99% fat, so much that the nucleus kind of gets squeezed out to the periphery. So a very unique characteristic there. Our next tissue is called reticular tissue. And reticular tissue is going to have a lot of those reticular protein fibers in them. Now, as I mentioned, reticular fibers can be found around a lot of different organs, but reticular tissue, where it's just this and not any other tissue around it, is really only found in structures associated with the immune system. So what we have is this kind of scaffolding or this ladder network of this big spider web looking thing of reticular fibers, and they're found in areas, like I mentioned, involved with the immune system, such as your spleen, all of your lymph nodes, and the bone marrow. The bone marrow is an area where we make all of our blood cells, but included in that are white blood cells that kill things. So with this, because this is found in immune functioning organs and structures, their main job is defense, is to kill things. So along these reticular fibers, it kind of creates this, like I said, this ladder network. And along these fibers, you have these cells. And these cells are designed to phagocytize or eat things, or just macrophages or white blood cells to destroy things. So it's basically a very important part of our body where we clean things up by killing them. And that's what your reticular tissue is mainly made for. Once again, only found in immune areas, spleen, lymph nodes, bone marrow, immune system structures. So that's really all we're going to talk about regarding reticular this semester. Once we get to the lymphatic and immune system, next semester we'll bring this up again. Then we have our dense fibrous tissues. And we have two different types of fibrous tissues in the body. We have dense irregular tissue, and we have dense regular tissue. So you can see their job, it's to connect things. We're going to have mainly, regardless if it's dense regular or dense irregular, it's just a whole bunch of collagen fibers. Collagen, collagen, collagen everywhere. And remember, our main purpose, our main function of collagen is strength. So you see the function of these tissues is to make the really, really strong stuff that holds things together. So your tendons are bands and bands of collagen fibers that connect a muscle to a bone. So when your muscles move, the reason why they don't tear or they don't pop off or anything like that is because they're anchored to a tendon, and that tendon is anchored to a very, very strong and sturdy bone. So you can lift really heavy weights or move that heavy table, and your muscles won't rupture because they're supported by these tendons connected to bones. And then, perhaps even stronger, you have the ligaments, and the ligaments is what connects your bones to your bones. So, for example, your elbow joint is connected by several different ligaments connecting your upper arm bone to your lower arm bones. So your elbow can do multiple different, well, it actually only moves in one plane, but it can lift multiple different things and not have the elbow joint compromised. So if it's dense regular tissue, we're going to have collagen fibers arranged really neatly in parallel rows. It's going to kind of look like this, just a whole bunch of strings of collagen fibers all go in the same direction. If we have dense irregular, it's going to be just this crazy mess of collagen fibers, just going all sorts of crazy, unique, whatever ways. And I'll show you a picture on the next slide. So typically where we find this, tendons, ligaments, the tendons and ligaments are mainly going to be dense regular, but in the areas surrounding these joints that have to move in multiple directions, you will find dense irregular as well. For example, your shoulder socket that moves up, down, left, right, superior, inferior, anterior, posterior, medial, lateral, all these different directions. We do have to have irregular fibers in that dense irregular tissue in that area. So let's move on to the next slide and I'll show you what this stuff actually looks like. Okay, so on the top slides, what you see is dense regular tissue, and just to kind of highlight it, on the top left, you're seeing all of these collagen proteins, and they're all kind of going superior to inferior, right, north to south. They're all kind of going the same direction. And then same thing on the picture on the top right, dense regular tissue, and it's just really kind of neat. You have a whole bunch of these pink fibers and also the white fibers. and they're all just kind of going this east to west orientation. So they're regular. They're all going along the same pathway. Now notice inside of this matrix, inside of all these collagen fibers, or dispersed throughout the collagen fibers, you have these nuclei-looking things. And they're actually not technically nuclei, they're cells. They're nuclei of cells, but the cells are really, really small. And those are the fibroblasts that we pointed out in the areolar tissue. So remember, fibro means fiber, and blast is a stem cell that makes things. So what do you think these fibroblasts make? What's their job? It's to make more collagen fibers, right? So as we do a crazy workout or something silly like lifting a ladder over our head that's too heavy for us or something, and we tear some of these collagen fibers in our tendons and ligaments, well, we can repair these. Fibroblasts, well, you don't really repair them. You can make new ones over time. The fibroblasts are designed to make new fibers. And then you can look below at dense irregular tissue, and you can see it's just a mess. Same thing, same ingredients. It's a bunch of collagen fibers all over the place, but that's what they're doing. They're going all sorts of different directions to help the tissue deal with stress in many different directions. And what we're going to see a lot of this, we're going to see a lot of dense irregular tissue in your skin. Underneath your epidermis, or your outside layer of your skin, is a lot of this dense irregular tissue. Because your skin can be pulled in multiple directions, right? The muscles underneath it can move in multiple directions. I can gain weight or lose weight, and that has to change my skin. I get cold and my skin kind of condenses and starts shivering, right? And then if I'm hot, my skin can become a little more stretchy perhaps and wet with sweat. So there's a lot of different conditions that can change, and therefore we need this kind of flexibility regarding the strength. It needs to be strong in multiple different directions. So that's our dense irregular tissue.